Unit 5, we will talk about warehouse management. Of course, the warehousing is one of the major logistic activities. This slide shows the boldface words there. Maintaining warehouses. We do the warehousing, manage the warehouse for the firms. So warehousing and materials management. In this unit, first we're going to see the role of warehousing in a global supply chain. And then we will talk about the materials handling process within the warehouse or distribution centers. Okay. Nowadays we use distribution centers, this term, much more than warehouses. Traditionally maybe we say warehouses, right? But now the distribution center, basically they have also the functions. Typically a warehouse should have. Also the distribution center have other tasks or other functions to perform. Nowadays we use the distribution center more. Okay. And in this unit we also talk about use automated equipment, automated system, okay, in a warehouse or in a distribution center. This is especially important. Modern warehouses or modern distribution centers. Let's first talk about the warehousing in the global logistics chain. Okay. Basically, we order inventory, we order items from our suppliers, right? And we wait for a certain period, so we say the lead time, and we receive the items from our suppliers. Then what? Then we need to put our received items in some places, right? Basically, we should have a warehouse, right? We should have a warehouse, or we should have a distribution center. We have a factory which has a warehouse or the functions for warehouse, the places, so that we can store these received items for a few days, so for some time, right? And then we will get these items from the warehouse storage areas and to do some processing, and then we finished the products. Then we send out these finished products, finished goods to other places, right? To our maybe downstream customers have their own warehouses, right? So the warehouses are very important for the received materials to be kept in that location for some time. Okay. However, we don't want to store too much inventory, right? As in the previous chapter we mentioned, we try to maintain a reasonable level of inventory, right? We don't maintain much more inventory than we need, right? Of course, we don't want to see, because we don't prepare enough inventory so that customers' needs cannot be fully satisfied. Okay, both are not good, right? So we try to maintain customer service level. That means we make sure that 95% of the time, okay, customers come to our store or place an order, we will have items available. We can right away arrange the delivery for our customers, right? However, we also need to consider minimize our inventory cost, right? So we have to do some trade-off, right? Between we satisfy our customers, we make our customer heavier, right? However, we keep our cost lower. Okay, these are two things that we have to trade off. You pursue one, and you have to pay the price for the other. For the warehouse management, we also need to have two objectives. One is to minimize the cost. The other is try to add value to the products, to the items when these items are kept in the warehouses. Otherwise, if your items are just stored in the warehouse and cannot be added value, why should you have to store these items in your warehouse? Why not just skip this step? Directly ship these items to the places that need these items, right? So we try to add value. So in the warehouse, or in a typical warehouse, we like to see it can perform some value-adding activities. So what is the value-adding activities? The value-adding activities are activities that can enhance the features of products so that the customer can perceive some very unique or particular benefits from these products, right? If they cannot have this kind of perceptions, okay, the value are not added, then you don't need to have this warehouse to exist. Okay. So in the global supply chain, you can see, okay, we have from the upstream to the downstream, okay, we have different organizations, different firms, and these individual firms, they have their own warehouses, right? They store the products in different forms. Okay? Some maybe the very beginning materials or components. Some maybe store the finished products, right? Especially when we go to the downstream site. Okay? Downstream organizations, they like the retailer distribution center or regional distribution centers. Basically, they store the finished products, but the manufacturer or the suppliers, okay, those firms, basically they store components or raw materials or work in process. These organizations, okay, typically will be in different nations for global supply chain. So we can see the slide shows the manufacturer have their immediate tier 1 suppliers, right? They have the warehouses to store the supplies or the materials from tier 1 suppliers, right? Also, the manufacturers have their warehouses to store the finished goods or work in process components in their factories, okay? But in the downstream parts, after manufacturer, basically they have a warehouse to store the finished goods, finished products. However, they not just only store the finished goods for some time, they also do some light processing. That means maybe they do some simple combinations, right? For example, a bicycle, maybe from the manufacturers, they send out the handles, the bicycle frames, the tires to the regional center or regional distribution center, etc. Okay, and then they do the combination, they do assembly of the bicycles also in the warehouse, right, according to the orders from their retailers or end customers, right? Because maybe they want to do the customization for their customers. Traditionally, they don't do this kind of simple assembly, but nowadays, more and more downstream warehouses perform this kind of tasks. So we can add value, okay, to a product by improving product's quality, by improving the services associated with the product. Maybe we provide the information associated with this product. Also, we can, by reducing the product's cost or by reducing the product's lead time. All these 4 different ways can add value to a product. Okay, so once your warehouse can do these 4 things, then we say this warehouse is doing the value-adding activities. Okay, otherwise, we don't need to have this warehouse to exist. Okay. So there are 4 kind of tasks that typically we can see in a warehouse that add value. The first one is create book consignment. Okay, that means to consolidate products from different suppliers, and they consolidate all these products and then ship this combination of the products to the downstream organizations. And also it can perform like a breaking book consignments to break a large consignment into a smaller one consignment. And then this smaller consignment may be again sent to downstream firms, downstream organizations along the supply chain. Not every firm do these two tasks at the same time, okay, because of their properties and their positions in the supply chain, on the supply chain. Some firms, some warehouses do the first one, the book consignment consolidation, and some warehouses downstream maybe do the consignments breaking, etc. And the third task is the light assembly, as I just mentioned. Okay. For example, some distribution centers, they can do the assembly of the bicycles, right? So this is a simple assembly, or we say combine the components, easily combine the components so that they can have the finished products in this warehouse. Okay. So nowadays some warehouse also perform this task. Okay. And the last one is smoothing supply to meet demand. Okay. Because of the time lag, time differences, we have some the goods produced in one country, and then we have to store in a warehouse so that we can ship to the market later on. So try to smoothing the supply to meet the demand. Okay, so this is also a task can be performed in the warehouse. Okay, so that's why we need some storage areas for the goods to stay in the warehouses. Okay, warehouse layout design. Of course, we need to have a very efficient and effective warehouse so that all these different types of tasks can be performed very well and very efficiently in the warehouse. Okay. Typically in a warehouse, we can see 4 functions. From the beginning, we get the orders from our suppliers. The first stage, this function will be goods arriving. Okay. For these functions, usually we have to unload goods from the trucks. We need to do some inspection. We need to check the quality to determine whether or not we will accept this delivery or not. If we decide to accept this delivery, then we need to record the date, okay, the amount, the quantity and the items that we accept, that we receive from which suppliers. We need to do this kind of recording, right? And then we put them into the storage areas, then go to the second function, right? Then you need to decide, you need to determine which locations that you want to store this particular delivery or these items, okay? And you have to also, again, record the information that where these items are stored, which locations where in the warehouse, okay? And later on, when you get a picking list, okay, from the maybe some information system, okay, and this picking system represents the orders from downstream customers. You have to pick items, okay, from the storage areas and do some packing. Okay. So then we move to the third function groups here, right? You do the picking and packing based on the picking list. And then, again, you have to move these items, already picked items and packed items, to the dispatch areas, right? And arrange delivery, arrange transportation, and tell the drivers where to send these goods. This is the last part of the warehouse function group. So this is 4 typical functions performed in the warehouse. Okay. And also you can see the dashed line here. What does this mean? This means that for some items, we don't need to put these items in the storage areas. We don't need to do further picking or packing. We don't need to do some light processing, light assembly, etc. Then, of course, for these items, you just directly receive items from suppliers and then move these items to the dispatch areas and wait for the trucks to transport these items to the downstream organization, to the next place. Okay, we call this cross-docking. That means we just skip the two functions, the store and some other processing tasks. So basically, this is a strategy for some so-called fast-moving products. For example, for the convenience store, you can see the convenience store, there are many items we call the fast-moving, because maybe within one day, all these items will be bought by consumers, right? Then we have to right away replenish these items for the retailers, right? So there's no need for us to store these items, okay, in the, say, distribution centers, warehouses, right? You just receive the goods from the suppliers, from the manufacturers, and then quickly arrange the transportation and then move to the retailers. Okay, so this is a cross-docking. Okay. Warehouse layout design. Okay, the purpose, of course, we try to have a suitable design so that these four functions can be performed very efficiently. There are several layout designs that we can consider, and each one of the possible designs has its advantages. Okay, so you can consider these designs based on the items or based on the spaces of your warehouses. Okay. Here I would mention to you three very common layout designs. Of course, there could be some other possible designs. Okay, but these three designs are very popular and very common for the industry to use. The first one is we call it straight flow layout design. This design from the goods receiving to the goods dispatching. Basically, there are straight line types. So for this kind of warehouse, okay, you have your goods receiving area. You have the receiving docks. Okay, maybe in the front of your warehouse. Maybe you have your shipping area in the back of your warehouse. Okay, in between, then you have the storage areas. You have some working stations, the picking phase, okay, to do some picking and packing, right? So this is a very straightforward design. Goods go from this direction all the way first to the storage areas. They stay there for some time, and then they are picked later on, and they are maybe repacked, or they are put on some labels. Maybe these labels is for the retailer, or we can call the in-store labels for the retailers. Okay, so this kind of simple processing. Okay, and as you can see, the areas ABC basically means we mentioned the ABC analysis in Unit 4, right? Basically, these are exactly the same meanings. Okay, we can also classify items, okay, according to a ABC analysis, and then we arrange the items received, okay, to be stored in different areas according to their categories. So in the areas A, we have those items which have a higher value than areas B and areas C. And we have to very closely monitor their inventory level, okay, because they account for very high percentage of the total inventory costs. So we need to very carefully to monitor their situations. Right? So we put them in the areas very close to the picking phase. So this is the straight flow layout design. And the next one, the U-shape U-flow design. The U-flow design, you can see that we have the goods receiving areas and the shipping area in the same site, okay, in the front door of the warehouse. Okay, but we need to differentiate. We need to have different areas for the trucks to park temporarily. Some trucks send the goods in, some were there in the shipping area to send the goods out. And here, once we receive the goods, we decide to accept these received items, namely use conveyors or use some other vehicles, other transport devices in the warehouses to move these items to those storage areas, right? We can have numbers for those storage areas, different locations, right? From this direction and then to their assigned location. And then we get a picking list from our system. Then we do the picking and packing. There is a conveyor from here to here and then to here. So this is a shape very similar to a U, right? Like a U, like a letter U, right? So we call this U-flow layout design. So once the conveyor, start moving from here and to the location 4, 3, 2, 1, and maybe we have 1 or 2 people stand here and look at the picking list and then pick items from these different locations and then place these items in the boxes, right? And then the conveyor will automatically move these boxes along this U shape, and then finally go to the shipping areas and wait for the trucks to deliver these already picked items. Okay, this is U shape. Next popular design is L-flow layout design. This design we use conveyor from here and then up to here. So this looks like a L. So we call this design a L-flow layout design. Very similar to the previous design, except we have only 2 sides from here, the picking phase, right? This part, lower part, and the right side. Okay, and then we have people stand behind the picking phase, right? And then just pick items from the storage locations. Right? Again, we have shipping areas here. We have goods receiving areas here. Once we receive goods from suppliers, we get items. We then use some device to move goods along this direction, okay, here, and over here to these different storage areas, right? And then once we do the picking and packing, we put all these items to be shipped here and wait for the trucks to ship these items to the downstream customers, move out here. So this is a L-flow layout design. Okay, these are 3 popular designs that we can consider. Okay, now we have the idea that we can use these possible designs, layout design for the warehouse, okay, based on our needs. And then next, we have to consider the capacity, okay, the capacity management. Right? You don't like to see you have a very big, large warehouse. However, you just use maybe 50% or 60% of the entire warehouse space, right? You try to have higher utilization as possible as you can, right? So usually we have to consider how big the warehouse will be, right? You need to decide a suitable one. You need to consider the future growth, right? But you have to consider very practically, right? You have to see in the future how much the demand will grow, will be growing, right? So usually we can use some metrics to measure the capacity utilization. Basically, we can measure the capacity in terms of inputs or in terms of outputs. I think most of the time people like to use output of a warehouse or some other facilities as the measure of the capacity. So, for example, here we use output to measure the capacity. Then we can see how well we make use of our warehouse. We have two possible metrics. One is capacity utilization. The capacity utilization means we compare the actual output to the design capacity. The design capacity is the maximum output that a facility or that a warehouse can generate. Okay, the maximum. That means if you can have this facility to run 24 hours a day, 7 days a week, and non-stop, then you can reach this maximum output. Of course, we all know this is not possible, right? Because sometimes we need to stop the facility, stop the function to wait for the regular maintenance, or wait for the unexpected maintenance for the machines, for the devices, etc., right? And sometimes we need to wait for the delivery from our suppliers because the suppliers are not so reliable because they don't send the items we need in time. So basically the design capacity, it's very difficult for us to get this level of output, right? Of course, we still can use this to measure how much we utilize our capacity, right? But we should keep in mind that use this as a denominator is not so suitable. So we can consider a much more practical one. We just take away those time that cannot be used, and for the remaining time that we can generate outputs, right? The most practical, most possible outputs as our denominator here. We call this effective capacity, right? Because we need to arrange the maintenance, right? We need to wait for the changeover. Now we handle this type of products, and then on we have to take care of other type of inventories, other type of works, and we need to in between we need to wait. We need to sacrifice some time that we just wait there. The time we can actually use to produce, to generate output, will give us this so-called effective capacity. This is much more practical. Then we compare again the actual output to this effective capacity. We can have a term for this. We call this capacity efficiency. Of course, we expect to see higher capacity efficiency, also higher capacity utilization. Right? If you see your capacity utilization is like maybe 50%, then maybe something wrong. You have to fix those problems in order to get higher utilization, capacity utilization. Right? I think 50% utilization is not a reasonable number, right? Basically, we would like to see like 80% or maybe even higher capacity utilization. But for the capacity efficiency, we maybe expect even higher, maybe 90%, 95%, etc. So we try to maintain a suitable capacity, right? We try to have a reasonable design capacity, okay? So how much will be the capacity? So this is the question need to be answered, the capacity management, right? We need to consider trade-off between minimizing capacity because we want to reduce cost and providing more capacity to be flexible to serve our customers. So these two things are contradictory, right? Trade-off. So if you have less capacity, maybe your customers will not be so happy because you are not so flexible. If they need more, you don't have more inventory for them because you are limited capacity, limited space, right? So, but we need to very carefully thinking about this capacity management. We just mentioned the capacity management. We need to set up a suitable capacity. Right? We have some choices. For example, here we can have these possible strategies. Of course, we can still have other possibilities. The first one is we just set up a constant capacity, level capacity. That means we keep a constant capacity. For example, capacity that our warehouse can handle for 1 week. Okay, we can handle 1,000 boxes, 1,000 cartons of the products. So that's a fixed capacity. Or we set up a capacity, so we have this big area that we can store how many units. Right? That's a fixed, constant level. No matter we have higher demand or we have lower demand, or we just have this constant level of capacity. This is the first strategy. The second strategy is chase demand. According to demand, we dynamically adjust our capacity. For example, we can hire temporary workers, right? Part-time workers, etc. Right? Because when we encounter higher demand, then we can hire more part-time workers. Otherwise, we can use fewer part-time workers. Okay. Maybe we can rent spaces from our local competitors or our local partners. Right? This is dynamically adjust capacity to match demand. So this is the second strategy, chase the demand. Okay. And the third capacity strategy is manage demand. That means they try to influence the demand by using some marketing techniques, marketing tools. For example, you can do some differentiation pricing in the peak hours or peak time, and you raise the price. During the off time, you can lower the price, you can reduce the price, so that some people can be attracted by these lower prices. They can consume these items during the off time because of this lower price motivations. Okay. And of course, we can have the combinations of the above three strategies. So this is some possible capacity strategies that we can consider. Okay. Let's talk about this very common phenomenon in the supply chain. We call this bullwhip effect. Okay. Basically, the bullwhip effect is a distortion of orders along the supply chain, especially when the upstream suppliers along the supply chain cannot see the actual demand of the end user markets. Then how do they prepare the inventory? They prepare their inventory. They make their production plans according to the orders from their immediate downstream firms, right? They base on that part to make their production plan. Okay? They are not using the actual demand of the end user market to do this kind of decisions. This is very dangerous because of the bullwhip effect. Okay? The bullwhip effect tells us very small fluctuations in the end customer demand usually result in amplification of the demand upstream. Okay. So we call this phenomenon demand amplification. So the higher upstream firm, okay, more variations they will encounter. A firm in a very upstream position along the supply chain, usually the firm will suffer from keeping too much inventory because they use the wrong information, they use not suitable information, and they use the orders from their immediate customers. So that's very dangerous. Okay. So the bullwhip effect will generate excess inventory. Of course, this excess inventory need additional warehouse capacity. Right? So accordingly, you will set up a not very practical capacity for your warehouse if you are a firm in the upstream positions along the supply chain. Okay. So of course this will has serious cost implications. That means you will spend a lot of money that actually don't need to spend. Okay. So the bullwhip effect discussed by practitioners, also by scholars in the past 10 to 15 years. Okay. Basically, they all agree that there are 5 causes that cause this phenomenon to occur. These 5 causes are non-zero lead times, demand signal processing, order batching, price variation, rationing, and gaming. Okay. The non-zero lead time, of course, typically we need to wait for some time for the items to arrive at the factories, right? Because there is a non-zero time, okay, the time lag between orders in the supply chain. And also because the upstream firms usually cannot have the information regarding the end customers' needs, the end user markets. So usually they try to prepare more items. They say they want to prepare the inventory at their place so that they can cover the demand that occurs during the lead time. Okay, so whenever there is a non-zero lead time, then the firms tend to prepare some additional safety stock, as we have seen previously in the Unit 4. Okay. The second cause is demand signal processing. Okay. Basically, each organization along the supply chain, they have to make their plan, their production plan, or their ordering plan according to some data. Okay. Basically, the upstream firms, the data they only have are the orders, okay, from their immediate customers. So typically, they will use this kind of historical data, okay, from their immediate customers as a basis to the forecast model and come up with a forecast demand. Okay. Based on this demand, they prepare their orders or they prepare their production schedule. If they consider the immediate orders as the actual market demand, then of course, typically this is not be the case, right? So if they consider the immediate orders will be the demand, they don't take care of the signal carefully, because the immediate customers' orders maybe already amplify the actual end customers' demand. So they have to very carefully look at these signals from their immediate customers. Okay? So typically people use wrong assumptions. So of course, they will make wrong decisions. So they will have higher additional extra inventories. Okay. So this is the second one, the demand signal processing. The third one is order batching. Order batching means usually we consider the ordering cost. We consider the storage cost. We try to trade off between these two costs. We will have a economic order quantity based on the formula. Okay, so we have a very economical order quantity. However, this economic order quantity, of course, will maybe minimize our cost in terms of the supply side. Okay, we can reasonably expect usage of resources. However, this idea, EOQ, the order batching, does not really reflect the actual demand. That means maybe the demand, say, maybe only 20 units. However, your formula tells you that the economic order quantity is 50, then you have to place an order of 50. However, actually, maybe the market demand is only 20, because you make this decision according to the conditions from the supply angles. Then, of course, then you will prepare more than demand. Okay, so this is also the reason for the bullwhip effect. The fourth one is the price variation. Usually, marketing people will use some promotion, especially the price promotions to boost sales during some period. So these price promotions, for example, say we have a promotion like 3 for the price of 2 items, right? You pay the price of 2 items, however, you get 3, right? Buy 2, get 1 free, something like that. Then what will the customers do? Okay, they just go ahead and pay the price of 2, but they get 3. They have more than they need. This will create higher fluctuations. The upstream firms, for this period, the demand is rather high. So accordingly, they should prepare more for the next period. But this is not the real situation, right? Because the customers buy more than they need. Maybe next period, they don't buy the items anymore, right? Maybe they wait for some time in the future to buy the items. Once you, based on this information, to prepare the production plans for the next period, then maybe you will have a lot of unsold items in the next period. Then you have to store those items in the warehouse and until the next period. So price variation can make the firms wrong decisions, prepare too much for the markets. Okay. So price variations are also a possible reason. The final one is rationing and gaming. Okay. Some customers, okay, they place an order from their suppliers. However, because of so many customers place orders, so this customer cannot get the amount that this customer needs. Right? Maybe this customer order, say, 100 units because of the competition among different customers. This customer only got, say, 80 units, right, instead of 100 units. Actually, this customer needs 100 units, right, 28 units short. Next time, next period, because he has this kind of experiences, he try to order more. This customer actually need 100 units. However, he placed an order to the supplier. Say, I want to order 120 units because of, again, the competition. The supplier does not have enough units for all the customers. However, because this guy ordered more, say, more than 120 units, but he has allocated, say, 100 units. Right? So if every customer has this kind of thinking, then everyone just tell the supplier wrong message. And they don't tell the supplier the true situation. Okay? They tell higher demand. So I need 120, but actually maybe he needs just maybe 100 or less than 100. So this kind of allocation game or rationing game, this is also will generate higher or bigger variations for the suppliers. They will see the demand fluctuation so bigger. These are 5 causes that can create the so-called bullwhip effect. Materials planning and control. In a warehouse or in a distribution center, basically we do the storage for the items. We also do the materials handling. We have to move the items from the receiving area to the storage area. We have to move these items from the storage area to the picking phase. We have to do the unpacking. We have to do the repacking. We have to put the in-store labels on the items, etc. All these are materials handling. Okay, and for the materials planning and control, we can use some automated systems. Right? And the MRP is an early version of this kind of system. Nowadays, we have a new name for MRP. Maybe you all have learned about the term ERP, right? But in the beginning, in 1970s, okay, the MRP, Materials Requirement Planning, was invented by an engineer in the IBM company. This MRP, Materials Requirements Planning, is a tool for us to plan and control the manufacture or the assembly of orders with dependent demand. Okay, what is dependent demand? Okay, there are two types of demands. One is independent demand. The other is dependent demand. Okay, for independent demand, okay, for example, if you are a bicycle retailers, okay, then you place an order to the suppliers. Right? So you say I want 100 bicycles. Basically, bicycle itself typically will be the demand for bicycles. Typically, will be independent demand. Okay. The other situation is, say you order tires, okay, from the suppliers, bicycle tires, okay. Then the bicycle tires is independent demand or dependent demand. Okay, two possibilities. Okay, if you are a bicycle assembly plant, okay, because you need to assemble 100 bicycles, so you purchase some bicycle tires from the suppliers. Then these bicycle tires, or the demand, belong to so-called the dependent demand, because you have the demand for the bicycles, so you will have the demand for the tires. Okay, so the tires now it's a so-called dependent demand. Okay, so for a final products, okay, the components that make up this product will belong to this kind of demand. Okay, the demand will belong to this kind, the so-called dependent demand. Okay. However, if you are a retailers sell bicycle tires, then you place an order to the tire suppliers, right? Then in your store, this demand for the tires will be independent demand. So it depends, okay? Depends whether or not you order these tires for assembly the bicycles, or you order these tires to sell to customers directly. For the independent demand type, how do we manage the inventory? We use the tools. We use the concepts in Unit 4. In Unit 4, we use inventory control systems, right? Both of the two control systems, and we set up the order quantity, etc., right? Reorder point, and so on. Right? But for the dependent demand, we don't do this. Right? We have several steps here. Okay. First, we have demand for the final products. This demand either comes from our forecast or from the actual orders. Then we put them together. This information tells us for the next several weeks, each week we should produce how many units of the final products. So this is so-called main production schedule for the final products that we are going to sell to our customers. Based on this production schedule, then we check what are those components or materials that we need in order to make these final products. Right? We refer to the BM table, bill of materials table. Okay. For example, the bicycle, we need tires, we need to have the frames, we need to have the handles, etc. Right? So for one bicycle, we need to have 2 tires, 1 frames, 1 handles, etc. Okay. We look at, refer to the BM table. And again, we also, because we know the quantities of the bicycles we're going to make, we can calculate how many tires that we need, how many handles that we need based on the BM table, bill of materials table information. Okay, and also we need to check our parts inventory database. See how many tires we still have in our warehouse, how many handles, how many frames we have in our warehouse, and we know whether or not we have enough the parts inventory for our bicycles production or not. Right? If we don't have enough components, we don't have enough parts for our production plan, then we have to go ahead, place orders to our suppliers to order these parts. Right? But because we have the production schedule for maybe next 8 weeks, we can calculate, right, when we need how many parts to arrive our warehouse, our factory, in order to let us can produce assemble the bicycles during that period of time. Okay. Then accordingly we can arrange these ordering plans. We don't need to order all the parts we needed in the beginning. We just say the first week we order some of the tires, and then maybe the second week or maybe third week we order another batch of the tires, right? So this system, okay, will help us plan this kind of orders, right? So that we can reduce our inventory costs. We don't need to, in the beginning, we order all of the parts of the components, and then we place in the storage areas. We don't need to do so. We can carefully plan the ordering periods so that when we need the items, they just arrive to the factories. Okay. So this system also can generate work orders to tell factories to produce, to assemble the products, how many each period of time. Okay. And also, as I just mentioned, can have the purchase order plans, materials usage plans for the parts, for the components. We can see these figures and we can have a much clearer idea here. The MRP system get input from demand forecast or from the orders from customers, together come up with work orders, and also check with the bill of materials and inventory available, the parts inventory, and they can the system can generate material plans or generate purchase orders automatically for the factory. So this is automated materials planning system and control system. Okay. But this is a Western thinking. This is a kind of so-called push system. We need to make forecast. Okay, we make forecast, and then we say we prepare. We make the products in advance and store in the warehouse for the customers to buy. But previous time we mentioned the pull system. That means we just wait for the customer to place an order, then we start do the production. Okay, different kind of thinking. This is Western thinking. The pull system is Japanese style thinking. Also, we can say that Japanese style thinking, JIT, just-in-time philosophy. Warehouse management systems and automation. For a modern warehouse or distribution centers, usually we will implement some information systems to help employees to perform the functions, the typical functions in the warehouse. Okay. In this figure, we can see the information system, WMS, Warehouse Management System. Okay. This is a information system that can help the 4 function groups we have mentioned, right? The goods receiving, put the goods into the storage areas, orders picking and packing, goods dispatching, and the automated information system can generate some exact instructions for the employees for them to perform their tasks. Of course, these warehouse information systems also interface with the company's MIS or company's ERP system. Okay. The ERP system maybe get orders from the customers. Then we can transmit the order information from this system to this system. And this system will generate, say, a picking list and tell people here to pick and pack the items for the orders. And then the system also will tell the people here that these orders will be sent to where to which customers, etc. This warehouse information system interface with the firm's information system and make the functions performed very smoothly in the warehouse. Okay. So as I mentioned, this warehouse management information system in the goods receiving system can capture the receipt. They can capture information from the receipt. Okay. So how many items arrived from which suppliers, etc. And this information will enter the system. Okay. Also, can create ID labels like barcode, and can place barcode on the items received. Right? And also can confirm the inspection, because we can check the orders placed to the suppliers, see if these items conform to the inspection. Whether or not, then we can determine whether or not to accept these items or not. Okay. For the second group, information system know where these items can be stored, which locations are available for these items to be stored. The information system can select available location. It can capture the location information that these items will be stored, and do the cycle counting and check how many units are there in the storage areas. Right? For the third group of functions, the information system can generate pick list and can help check whether or not the employees pick the correct items from the picking list. Okay. And for the final functions, the system can produce the load sequence, because maybe these items will be sent to several retailers, right? We can put the sequence, put these items for different retailers according to their distance from our warehouse, right? We can place the farthest areas in the truck first, and then the most recent retailer items last, right? So that when the trucks go to those retailers, the truck drivers can save time, because each time when this driver arrives at a store, he can just check away the items easily from the truck. Okay. So the load sequence is also very important, and because the system can have the information about these retailers, so the system can tell the people in the dispatching area, so what sequence you should arrange for this unloading. Okay. Also can help check the inspection that customers expect, and also recode the dispatch information. That means what time and how many units, what are those units are loaded in the trucks and will be sent to the customers, etc. Okay. So basically, these information systems can very precisely, accurately help the employees to perform all these functions, all these activities, and of course will save a lot of time, and we can use fewer people to perform these functions. Although we need to invest money to install this system, however, it's worthwhile because we can use fewer people to perform the functions in the warehouse, and we can enhance our service levels for our customers. However, although we can have this automated information systems in a warehouse, we still need to consider the human factors. That means we still need to consider whether or not our employees in the warehouse will get bored because they just do the very simple task. They perform very simple task repeatedly every day. They will be getting bored, right? So we try to rotate their positions, let them perform different functions, or we let one people to perform multiple tasks, right? And so that they will not get bored. They can be motivated. So I think this will happen not just in the warehouse, in the factory. If we implement automated equipment or automated information system, we need to still do the same thing. We need to do the job redesign so that we can motivate our employees, right? So that is, we have to pay attention to the equilibrium between the social system, the people parts, and the technical system, right? We have to balance, because eventually the technical system still need to be performed by people. If you don't have satisfied employees, how can you perform this equipment efficiently, effectively? So we need to still come back to the human factor considerations. Okay, that's all for today.